we're going to look at the factor theorem. So our factor theorem says let f of x be a polynomial, which is what we've been working with. If f of c is 0, so if our y value, when we plug in x, we plug in c for x and we get 0, then x minus c is a factor of f of x, which should make sense because this means that our y value is 0. So that means if our y value is 0, it's somewhere along the x-axis. Well, we know that on our x-axis, those are called x-intercepts, roots, solutions, or factors. So that means that this thing is a factor of f of x. Notice from here to here, the sign changed, just like we've done normally. We also have the other direction. So if you know if if x minus c is a factor of f of x, then you know f of c is 0. So what we can do is we can use the remainder theorem to decide if something is a factor or not. So determine if a binomial is a factor of the given polynomial. How do we know? So here, if I want to determine if this is a factor, I'm going to synthetically divide. I'm going to change the sign because it's written as x plus or minus a number. In this case, it's an n. So we're going to have change the sign from here to here. I check my polynomial, cube, squared, 1, none. I'm not missing any powers. It's going in descending order. I should probably make that a little higher so I have space to write. So, excuse me. So then we've got 4, -6, -44, and 16. So I bring down the 4. 4 times 4 is 16. I add -6 plus 16. That gives us 10. Then I do 4 times 10 is 40. -44, sorry, I don't mean to keep moving the paper. -44 plus 40 gives us -4. And then we do 4 times -4 is -16. And then I add straight down, which gives us 0. Right. So this thing here, notice it says if f of c is 0, well, from our remainder theorem, we know that this means that f of c is 0, or in this case, it would be that f of 4 is 0. So then we know that n, because that's our variable this time, minus 4 is a factor. So this thing that we synthetically divided by is a factor, which also means that 4 is an x-intercept or our root or solution or 0. So if we look at the next one, we're doing the same thing. We're deciding, is it a factor or not? Oh, wait. So we didn't say why. We know that n minus 4 is a factor because the remainder was 0. So if our remainder is 0, then we can tell that the c value is a factor. So we're going to try on this one. So I have this as b minus 6, so it's the x value, or in this case b, plus or minus a number, so I have to change the sign. So this goes to positive 6. I check my polynomial, 4, 3, 2, 1, none. I haven't skipped any powers, I'm in descending order, so 5, -28, -5, -43, and 9. So I bring down the 5, 6 times 5 gives us 30, -28 plus 30 is 2, 6 times 2 is 12, -5 plus 12 is 7, 7 times 6 is 42, -43 plus 42 is -1, 6 times -1 is -6, 9 plus -6 is 3. So that means that we've got f of positive 6, because I have to change the sign, is 3. Okay. So our remainder is not 0, so that means that b minus 6 is not a factor since the remainder is not 0. If the remainder is not 0, it's not a factor. If the remainder is 0, it's a factor. So that will help us determine if it's a factor or not, and that's what our factor theorem helps us figure out.